I'm talking about assessing nutrient status and removal from hazelnut varieties in Australian climates. This is a project which runs over a number of sites and climates. And I will give a little bit of background before I go to the actual trials. So optimum nutrient levels are important for good tree growth and also nut composition. Therefore, you need a nutrient fertilizer management strategy, which is supported by soil assessment and analysis, but also it's important to integrate to an assessment of the hazelnut tree development in regard to quality and yield. But most importantly, to have an indication of nutrient status by assessing leaf nutrients in summer. The nutrient yield levels, the nutrient yield levels are also assessed or validated by nutrient removal, which occurred by the nut harvest. And of course, the nutrient reserves and other nutrients are important for tree growth when the soil is still cold for the early growth. And regarding the hazelnut production in the world, Australia is a very small producer, and it doesn't make it actually on this graph. Most importantly, there's Turkey with enormous production, followed by Italy, which does a lot of the processing of the hazelnuts. But there's also Chile, which is on the southern hemisphere as Australia, and that provides the opportunity to produce nuts in the off-season. So in Australia, there are some present production areas which are in the cool climate regions of New South Wales, Victoria, and Tasmania. And then there are potential areas which are in the semi-arid climates further inland in our large irrigation areas, which obtain their water from the Murray-Darling system. So for this, one of the things is to identify suitable production regions. And for this, we established orchards a while back in the Murray and the Riverina. These are both semi-arid regions. And so the rainfall is 300 and 400, about 400. And then a region which we know that can grow reasonably well in the central tableland, which is which nearly about 1,000 meters and quite a lot more rain. So the other issue is to identify hazelnut varieties which are more suited. There are 3 primary varieties. So they're planted in larger areas, and then we have 12 additional varieties, and they're all replicated in some way. So the 3 primary ones, which I will focus on mostly, is Barcelona and the 2 Toner varieties at the bottom of this list on the left. So the 3 locations vary, of course, not only in the climate, also in the soil. We have sandy soils in the Murray, in the Riverina, they're lighter soils, and we have soils of volcanic origin in the central tablelands. As I mentioned, there are 15 varieties. They're planted in 2013. They have a row spacing and tree spacing 5 by 4 meters. And that relates to 500 trees eventually per hectare. And they're trained in a vast system. So water supplied by drip irrigation, but 2 irrigation lines, and the fertilizer applied by fertigation. The nutrient water application, of course, varies a little bit between the sites. So the tree growth and development during the establishment showed there's firstly a clear difference between varieties. Barcelona developed particularly well in the cooler climates, but there's a difference also between the two semi-arid climates in the development and growth. So the phenology differs as well, and we now really at this stage at the moment, basically, even it's winter, that's when this flowering is happening. So if you look at Barcelona, there are some difference in flowering dates. So one of the Semiarid, the Murray is a bit later than the other two, but this is not always the same for every variety. We see here that San Giovanni is earlier, or Tono is earlier in the temperate climate, and the Semiarid is later. And that again is different with Tono Romana, which are flowering later in the temperate. So that's an important consideration when you take also nutrient status assessments. So the soil soil sample was assessed at 2 levels, at 30 and 60 centimeter at each side. The leaves were collected for this presentation at 2 growing seasons from 5 varieties, the 3 major ones and 2 of the less pronounced ones. From a shoot, these were taken in the middle of a shoot from moderate biggest shoots. So, and harvest also from the temperate location, 50 nuts per plot were collected at harvest to assess nutrient removal. Of course, then the samples were dried, ground, and then analyzed for the various nutrients. So in the soil, we can see the colors indicate either high values in too high values out of the standard range in blue, or too low in the yellow or orange. So particular Murray had issues with the soil pH. There was a high copper levels in the tablelands in the Riverina, but most likely it has to do something with sprays. But there are also some really low levels for phosphorus in the tablelands, Riverina and Murray. So the other and the carbon was slightly too low in a number of locations. So from there we go to the leaf nutrient concentrations, and this is the first year. As I mentioned, there was sample in summer, and we had particular an issue. Again, we have the color to indicate where we have low levels, and so red is deficient, so below the optimal. So we have really low levels in all varieties in that year for the tablelands. There's some issues here also with phosphorus and zinc, and that zinc issue was particular an issue also in the Murray. So there's something to address. Of course, we have high boron levels, which is expected in irrigation areas to some extent. We also have a number of high levels in manganese and iron. So the following year, they seem to be better settled or better balanced. And the magnesium levels, of course, the fertigation was adjusted as well. So we have less of an issue with magnesium now in all locations, particularly where the tablelands had issues there with below optimal levels. Boron also came back a bit, but there's still some improvement to do to get them right, all in a to balance nutrient levels. So in the central tablelands, we also looked at 2 other times in the leaf for leaf nutrients. So this was in spring and autumn, so not just in summer. And what we observed in the first season, in this last season, sorry, we have the usual decline in nitrogen and potassium during the season in leaves, and an increase in calcium. So and that increase is visible, is apparent also for iron manganese. So similar pattern with Barcelona. We have to decline during the season in nutrient levels, in particular in the macronutrients except calcium, and the increase for manganese and iron. But there's also difference in variety behavior. So we find much or considerable higher levels for nitrogen in Tonda Romana at the beginning of the season, and for iron at the end of the season. That will, of course, help to be more accurate with nutrient application to understand this dynamics. So when you look at yields, and again, this is in the tablelands. We have to protect the nuts from being eaten by the vicious Australian birds. So Barcelona showed the highest yields, and that's why we have actual and potential yields, because we need to estimate what was actually taken by the birds. So we expect that the yield will still about double in the coming years. But it's clearly a difference from the yield level when you think about removal of nutrients. So the concentrations of the micronutrients are in this table. So again, we have the 3 varieties, and you can see for nitrogen, there's also Tonda Romana, as indicated earlier in the leaves, has higher nitrogen levels than the other 2 varieties. So in regard to micronutrients, there's iron, which is much higher than in Barcelona compared to the other varieties. So if you relate that to removal, and that's just kilogram by ton in the shell removed from the orchard, because of the higher concentration of nitrogen, of any other nutrients, that then relates to higher amounts of nitrogen removed from the orchard, and with expected yield going up, you can multiply that by 5, and that would be a removal of nitrogen from the orchard, and this multiplication would be the same for the other nutrients. Of course, for the micronutrients, this amount are more in the gram amounts than in the kilogram amounts. So in summary, we have 3 experimental sites, 2 in semi-arid climate and 1 in cool temperate climate. We focus on the key varieties, Barcelona, Tonda Romana, and Tonda Greffoni. And we observed differences, particularly one side had a relatively high soil pH, and all the Australian soils are pretty old, sorry for this. And some of the organic carbon was far below the optimal range, but the cation balance was pretty good. There are nutrients a difference between sites, but also between varieties. There is a change during the growing season, depending up or down, depending on the nutrients. We can have substantial amount of removal from the orchard. We try to get more the seasonal requirements. So when, well, firstly, ranges at different times of the season, but also how much these trees need at certain times of the season. So for that, we need to understand better the nutrient dynamics and the uptake by the trees. So I'd like to acknowledge the funding body which contributes to this project, AgriFutures Australia, and the industry partner AgriAustralis, and one of the TA, which doesn't work on the project but had considerable amount, considerably input earlier in this work. Thank you for your attention.